with this. When it says write expressions to match the diagrams, then evaluate. So again, the word evaluate really means solve. Okay. So I'm going to skip those for right now. So write an expression to match. So I skipped down to number 2. So write an expression to match. Can y'all hurry up and get the snacks eaten, because the crinkling of the bags, I really cannot concentrate with the crinkling of the bags. So we have 1/6 the sum of 16 and 20. So if I were going to use the highlighters, one of the things that I'm going to do with the highlighters is I'm going to separate what I'm working on. Now, it's been a while since we've done this, but the highlighters are there to help me kind of isolate the things that I'm doing. So I have 1/6. What am I taking 1/6 of? Well, I'm taking 1/6 the sum of 16 and 20. So when I have the word sum, what does that mean? Add. What am I adding? 16 and 20. So I know that here I have 16 plus 20. And anytime I have the words like a, let me not do this. Like, this is just like a little square. A fraction, it's like just a symbol for a fraction. Fraction, the. Okay, you see this? I've got a fraction. This is a fraction. Okay, fraction, the. Or a fraction of. Those are things that really mean multiply. So when you see 1/6 the, what am I going to do with 1/6? I'm going to take 1/6 and multiply the sum of 16 and 20. So do I need to do parentheses around 1/6 or parentheses around 16 and 20? Parentheses around 16 and 20, because it's 1/6 the sum. So I need to add these first and then multiply it by 1/6. See, it's been a while since we've done it, but that's why we need to separate the things. 1/6 the sum of 16 and 20. 1/6 the sum of 16 and 20. Okay. Subtract 5 from 1/3 of 23. Now that one is worded so awful. Subtract 5 from. So when it's 5 from, does 5 go in the front or 5 go in the back? 5 from. The back, because I'm taking 5 out of it. So 5 needs to go in the back because I'm taking 5 from it. Because that was one that y'all struggled with that so much. From 1/3 of 23. What does a fraction of mean? Multiply. So how am I going to write 1/3 of 23? How am I going to write this? 1/3 times 23. Yes, sir. Yep, that was my next step. Where do they go? Around the red or around the blue? Around the red. So I want to know what to do first. So, but even though this is in the front, it's not what I do first. Because I'm subtracting 5 from 1/3 of 23. How are y'all doing? Is it slowly coming back? Like you haven't ridden a bike for like 10 years? And you're like, oh, okay, slowly. The only difference is there's a fraction in it. Everything else is the same. There's just a fraction in it. Oh, we didn't solve them. You're right. You're right. We didn't evaluate. Okay. So why don't you go ahead and evaluate 2A and 2B? With your order of operations, what needs to be done first? The parentheses. 16 plus 20 is what? 36. 1/6 of 36. If you do standard, you get 36 over 6. Do not leave improper fractions as your answer. You have to divide that. So you end up 36 divided by 6 is 6. Either way, no matter what, you end up with 6 as your answer. Do not leave improper fractions as your answer. You can have improper in your work, but you cannot leave it as your answer. If you leave it as your answer, I'm marking it wrong. You cannot do, 36 over 6, I'm done. No, you're not. This late in the game, you should not be leaving improper fractions as your answer. If you did 2.0, 6 can go into 6 one time. 6 can go into 36 6 times. 1 times 6 is 6. 1 times 1 is 1. Either way, you still get 6. Now, this one might have thrown a couple people for a loop. Just a couple, not a whole lot. You might have been able to do the first part, but you might not have known what to do for the second part, and that's okay. So, 1/3 of 23, you cannot force standard 2.0 because 3 cannot go into 23 evenly. If it cannot go in there, you can't do it. So you have to do straight across. 23/3, which you would end up with 7 2/3. I'm not finished. I still have to subtract 5. 7 2/3 minus 5. Now, okay, let me do a little bit here. I know that we have done, and look here, Jasmine, look here. We have done in the past where I would say you cannot have, I think the problem was like this, where I would say you can't do it really. You can, but you can't. It's a whole number in the front, and you would have to mess with this fraction, Kylie, where you have to mess with the fraction here and make it this, okay? Where you can, you can't, but you can, right? With this in the back, if I have 7 whole pizzas and 2/3 of a pizza on my counter, can I give away 5 whole pizzas? No. Yeah. So If I have a whole number, I can take away a whole number. The only time that it's tricky is when the whole number is in the front. That's when I have to mess with it. I don't have to do anything. That's like 5 with 0 over 0. I don't have to do the messing with the fraction. Because then, if you mess with it, you're going to do 4 3/3, and then you've got 2 minus 3. I can't do that. And then you're having to mess the fraction in the front. It's really weird. 7 minus 5. 2 2/3. And you're done. Because if you have 7 whole pizzas and 2/3 of a pizza, I can take away 5 whole pizzas. Just go here, you're done. And you've got 2 whole pizzas left over and that 2/3 that no one wanted. And you're done. Three times as much as the sum of 3/4 and 2/6. Now that's sum. Uh-oh. Oh, God. Common denominator, like you didn't just finish doing it. 3 times as much as the sum of 3/4 and 2/6. Ooh. See if you can write that expression and evaluate it. I'm on pins and needles to see what you write. All right, looking up. So the sum of 3, so I want you to at least check your expression and see if you wrote it right. So the sum of 3/4 and 2/6. The sum of those. You get that?
Yes, sir. Yeah.
3 times as much.
Yay.
So you did that. So now it's like the evaluating is where you're kind of getting lost in the execution.
Yeah.
A couple of you, yes. Okay. You can't add those. You need a common denominator. You're not multiplying these, you're adding them. Least, what? I know I did not hear 10. Okay, so I'd love to know how anywhere in the scheme of the 4s you've got a 10, and how anywhere in the 6s you've got a 10. When have I ever taught you to add your denominator? Never. No. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. Oh, look, so we do remember how to find the least common multiple, to find the common denominator, which is not 10. So 12. 4 to get to 12 is 3. 6 to get to 12 is 2. And you actually end up with 13/12 here. That's 1 and 1 half. So there you go. That's the polite thing. Are you okay? You all right? So you have to 3 times the sum of this, which is 13/12. So one thing that you can do is go ahead and multiply this. You can do this because it's not your final answer, or make it a mix, one or the other. So 3 times 13 is 39/12. 12 goes into 39 3 times 3/12. Simplified. 3 and 1 4. Or some of you went ahead and turned this into 1 and 1/12, and then you had to multiply 3 by that. But you didn't know how to do a whole number times a mixed fraction. We will do that this quarter. And I think I might have shown you how to do that briefly before Scantron. I know I showed some people how to do it. But it's essentially repeated addition. Sit up. So, and I did do this on the board before we went and did Scantron. So it's whole times the whole. 3. Whole times the numerator. 3. Do you add your denominators?
No.
No. So I don't touch my denominator. 12. So again, and you would be surprised the number of people who get that wrong. So again, I need to simplify that. 3 and 1, 4. Oh, it's 10, not 11. I was about to be like, why are they backing up? It's 10. Okay. So I want you to do letter D. 2/5 of the product of 5, 6, and 42. So if you are solving this, do this, you get 35, she is fine. 2/5, you can do this, that's how you get 14. If you did it that way, unless you did regular standard algorithm, your numbers would be a whole lot bigger. Oh my gosh, you're copying my work. You should have had this done. That was super easy. You should have had it done. You shouldn't be copying my stuff. You had plenty of time to get that done. Oh, this is another one. Copies of. What do you think it means when you have copies of something? It's not on your chart. So, multiply. Get this out of my sight. So, if we are, I'm not even looking at it. So, when we have a fraction of or whatever, so if I have, a 6, and then I have like 8 copies of 6. What do you think I'm doing with it? So I could be doing repeated addition, which is the same thing as multiplication. So if you have copies of, that is multiplying. So 8 copies of the sum of 4/3. 4/3. You need to pay attention to the fact that says 4/3 and not 4. 4/3 and 2 more. The sum of 4/3 and 2 more. 2 more. Success. Okay. So 8 copies of the sum of 4/3 and 2 more. 2 more. So that is your expression. Okay. Now, there's 2 ways that you could solve this. I don't know why I picked up another pen. I chose one way to do it just because I was so bothered by that improper fraction in the middle of the problem, because it was easier for me to solve it by turning this into a mix. You could leave it and add it. I didn't like, I'm not looking at it. So I went ahead and turned this into a mixed fraction. Now, normally I say, in the grand scheme of things, just leave it improper. That's easier, like when you're multiplying, dividing, and whatnot. But for this, since I have an improper and a whole number, no. So this, I turned it into 1 1/3. So now I can add that to 2. I don't have to. I could have made it 2 4/3, but that is ugly. I don't like that. Plus 2. So if I have 1 whole pizza and 1/3 of a pizza, and then I've got 2 pizzas over here, how many pizzas do I have? 3 1/3. I can add those together. I don't have to find a common denominator. That's just 2 whole uncut pizzas. I do not have to do anything over here. So now I can take this, multiply it by 8. 8 times the whole, 8 times the numerator. 24 8/3. I cannot leave an improper fraction in my answer. 24 8/3, negatory, good buddy. Cannot leave that. I can't ignore the 24 when I'm done, but I do have to deal with this. 8 goes in, 3 goes into 8. 2 times, once, really? 2 times. And I'm left with 2/3. 3 into 8, 2, 6, 2. 2 2/3. Plus the original 24. 26 2/3. What? What should I? 4 times as much as 1/3. 1/3 of 8. So they've got fractions written as words. 4 times as much as 1/3 of 8. Okay. 4 times as much as 1/3 of 8. 1/3 times 8. 3 cannot go into 8, so you just have to do it. 8/3. 4 times 8/3. Now you can just go across and get 32 over 3, and then you'll get 10 2/3. That's actually easier than doing it the other way. Because if you do where you make, do you see where like leaving it improper is sometimes easier? Because if I take in the middle of the problem and make, what? Oh, I thought you were like asking a question. If I take this and I make it mixed in the middle of the problem, Andrew, then this would be 4 times 2 2/3. Well, then I get, 4 times 2 is 8. 4 times 2 is 8. 8 8/3, and then I'm stuck having to go, okay, 8/3, again, that's 2 2/3. And then it's 8 plus 2 2/3, which is 10 2/3. So I'm kind of having to do more work down here because I did going from improper to mixed in the middle of the problem, where it was easier just leaving it alone and doing standard algorithm just in the middle of the problem, just leaving it alone and waiting until you get to the end. Because sometimes it'll fix itself before you get down to the very end. Sometimes it'll just, solve itself. What? How can what? Okay, now this problem, it's a little bit different. You see that it's not asking you to write an expression. What it's asking you to do, circle the expressions that give the same product as 4/5 times 7. Explain how you know. Now, for me, the only way that I would really be explaining for me personally, because sometimes I don't trust myself, is I would solve all of them. Because that's just me. I would show my work. Because some of you don't do it, and you just kind of look at it and go, that one, that one, that one. And you don't really do any of the work. You guess. So if this were actually a test question, I would be telling you, you have to show your work. Solve all of them. So 4/5 times 7, I would say solve that one. So 4/5 times 7, you get 28/5, which, you know, if you want to go ahead and make it mixed or whatever, fine. But in the grand scheme of things with this problem, for right now, I'm going to leave it mixed. Not mixed, oh my gosh, improper. Because it makes it faster to figure out which ones of these will give you the same product. Okay, so I'm going to look for which ones down here would give me 28/5. So I want you, so this one would be 4 divided by 7 times 5. Would that one give me 28, bless you, 28 divided by 5? No. 7 divided by 5 times 4. Remember, with PEMDAS, please excuse my dear Aunt Sally. Since there are no parentheses, when you do, and see, that's, I'm glad you said that. If you write it like this, then you think multiplication goes first, right? I know. When I started writing it now, and even on the chart that I gave you, they've got multiplication first. However, whenever I write it, I put them side by side. When I write addition and subtraction, I write them side by side because they are equally important. When they are in the same sentence like this, you go left to right like a book. You go left to right like a book, only when that's all you have in the sentence. If I have like addition and multiplication, I don't go left to right. I do multiplication first. So since this one has division and multiplication first, then I need to do the division first. So 7, I'm going to write it like a fraction. 7 divided by 5 times 4. Is that going to give me this? No. Now that these have the parentheses, now I know how I can write it. 4 times 7 divided by 5. 4 divided by 5 times 7. 4 times 7/5. 7 times 4/5. So I want you to circle the ones that you think will give you this. Go ahead and do that now. The ones that weren't really, well, explain how you know. And the easiest way is to actually try to get to 28/5. To me, that's the easiest justification. I just answered your question. Okay, so the first one ends up being 4/35. Will that one work? No. 7 over 20. No. 4 times 7, 28, divided by 5. Is that the same thing?
Yes.
Yes. So that one's the same. 4 divided by 5 times 7. So 4 over 35. Is that the same thing? No. 4 times 7 over 5, 28 over 5. Is that the same thing? Yes. 7 times 4 fifths, 7 over 1, 28 over 5. Is that the same thing?
Mm-hmm.
Yes. So it should be the third one, the fifth one, and the sixth one that you should have circled. And nothing else. Okay. Now, not only do you have to be able to evaluate those, you have to compare your answers. So you have to solve them correctly and know your numbers to be able to do less than, greater than, or equal to. So solve, compare. Mm-hmm. No, I want you to show your work because I know some people would go, here, here, here. And they wouldn't do a thing. You have to show your work in this room every time, all the time. Every time, all the time. 3 times 2/3. 3 times 2. 6. 1 times 3. 3. That's also improper. What is 6/3? 2. Which one's bigger? A or B?
A.
So if you looked at this and you know your order of operations, I had multiplication, addition, multiplication. Multiplication has to be done before addition. So I had to pick out the things that had to be done first. It was 4 times 2 plus 4 times 2/3. So I had to pull out the things that were being multiplied, take those products, add them together. I could not go left to right because that plus sign was in the middle. If there had not been that plus sign, I could have just gone left to right. If there had been a division sign in there, I would have gone left to right. But there was a plus sign, so I had to be like, the plus sign was like a stop sign. It was like, work, stop, work, and then I had to like smash them together. 5 times 3/4. That's 15 fourths times 2/5. What I'm not doing in the middle of my problem is making this a mixed fraction because you cannot, one, not listen to your teacher and worry about eraser shadings right now. You need to be listening. What I cannot do is make this a mixed fraction because you cannot multiply a mixed fraction by a fraction. You can do a mixed fraction by a whole number, but you cannot do a mixed fraction by a fraction. I would have had to go back and make it improper. That's why most of the time I tell you just to leave it improper because you can't do it. 15 times 2 is 30. 4 times 5 is 20. I mean, I could have simplified within the problem, and while I was working, I was like, stupid, I could have done that right in the middle of the problem, but I didn't think about it. 20 goes into 30 once with a remainder of 10 over 20, and I could simplify that with 1 and 1/2. So if I had, stop playing with that Velcro, it's very distracting. If I had done the 2.0, I could have done both ways. So I could do this way. 5 goes into 15. 5 goes into 5 once. 5 goes into 15 3 times. I could go that way. And I could do, I can go this way. It doesn't have to just be, you know, bottom going this way. 2 goes into 2 once. 2 goes into 6. Because then I would have 3 halves. 2 goes into 3 once with 1 half. As long as you're going this way and you can easily have a number going into the other one evenly. Okay? Did you see what I did? It cannot be 8 going into 10 or 3 going into 7. It has to go in evenly. Okay? You can't just make stuff up. Be like, oh yeah, it goes in there. No, it doesn't. That one did, but some of y'all do the things that don't work. So 1 1/2 is over here. 5 times 3/4. 4 can't go into 5, so I cannot do 2.0 here. 15/4 times 2 sevenths. Okay, 7 cannot go into 15, so I'm not going to do that one. 2 can go into 4. So I've got 15 over 14. 1 and 1, 14. So 1 1/2, 1 and 1, 14. Which one do you think is bigger? Yeah, 1. 1 and 1/2. The bigger the denominator, the smaller the piece. And I've only got 1 as my numerator. That's a tiny piece. Half is, you know, half of the thing. Hey, no, you checking my mouth. Okay, you were kind of going like this. I thought you were checking my mouth. Okay. Sometimes I mess up. So if you see it and you're like, okay, you're wrong. Okay. So 3. That's plus sign. That's plus sign, right?
Yeah.
Okay. Let's see, it's blurry on here. Okay, so 3. Now, yeah, there's a multiplication sign out here, an addition sign here, but it's in parentheses, so I do it first. Can you stop moving the paper and pay attention? Pay attention. Put the paper down. Paper down. 3 plus 15/12. 3 and 15/12. I'm leaving it like it is. 3 times 3 and 15/12. So, whole to the whole, 9. 3 times 15, 45. That is a gnarly improper fraction. Leave my denominator. I cannot leave that alone. So, 45/12. 12 goes into 45 3 times. So, this becomes 3 and 9/12. 9 plus 3 is 12, and 9/12. And I know that can be simplified, and if I have to, I will. But it looks like I might have a 12 over here as my denominator. 3 times 3 is 9, plus 15/12. Look at there. 9 and 15/12. So if I, 12 goes into 15 once. Oh, let's see if I can actually write numbers. So I have 10 and 3/12. So if you weren't careful, you would actually think that they were equal and be like, oh, they have a 9. They're equal. Are they? No. So you should have that. No, no.